name's Jack. I work at the Web3 Foundation, and yeah, appreciate everyone making the time on this Wednesday and checking it out too. Distributed Global, and thank you Distributed Global for letting us use the space. We have a lot of fun stuff planned for tonight. A lot of cool teams who we've had presentations with before. So first is going to be a little bit about Polkadot from Björn and then Rob. Björn's from Parity Technologies. They're building the first implementation of Polkadot, and then Rob is just all Polkadot. He's the co-founder. He's developing it. And then we're going to have a short break, and then we're going to hear from Patrick, local company called Clovyr. He originally was at JP Morgan doing their Quorum-based chain. And then CoinFund. We're going to hear from Jake, who founded CoinFund. So thanks again for coming out. Before we get started, Lane Reddig from Crypto NYC is going to...
Thanks, Jack. Hey, guys. My name is Lane, and yeah, so there's an incredible array of people speaking tonight, so super thrilled to be here. Thank you, everyone, for coming. Just wanted to quickly let you guys know, so I am on a team of an organization called Crypto NYC. So Crypto NYC is a 100% Web3 and blockchain-focused co-working space. We have a beautiful space on 39th Street. We also team up with amazing teams like these guys when people are in town to try to just curate amazing events, amazing people. We do a weekly newsletter of all the best events in New York. We have a very active Telegram group. We're kicking off soon a monthly super deep dive Ethereum tech meetup as well. So check out cryptonyc.org. And if the stuff you hear tonight about amazing projects like Polkadot excite you and you're sort of hungry for more, yeah, just look for Crypto NYC, and we'd love to welcome you guys into our community as well. Thanks. Oh, sorry. I also need to tell you, I'm wearing this beautiful T-shirt because there's this amazing summit coming up. I'm not on the Web3 team, but I'm super excited to be there. So yeah, if you're going to be, especially if you're going to be in Europe anyway for DevCon, or even if you're not, come check this out in Berlin in 3 weeks. It's a lot bigger than Ethereum. There's really amazing people like Juan Benet from Protocol Labs is going to be there, and Dom Williams of Dfinity is going to be there. So a lot of the great minds and great thinkers in the space just talking about the future of the web and how we can all change the world together. So cool event.
Okay, sweet. First, we're going to hear from Björn a little bit about Polkadot and what we've been working on.
Hello, everybody. I just got in from Berlin. Happy German Day of Unity, right, by the way? And even though I won't give you an excursus on German history today, I do want to tell you how we are looking to unite all the blockchains. So welcome to Polkadot and Parity today. So a bit about our company, Parity Technologies, right? 3 years ago, we got started. We built one of the first Ethereum clients. Since then, we have grown to a team of over 60 researchers and developers. Over 50, or I think even 55 of them are developers. We are still pretty lean on the business side and all the other sides, and really dig into building out the infrastructure that's needed to make this Web3 happen. I want to give you a 2-minute introduction from a high-level tech perspective to a bit of set the scene for what's coming within the next 50 minutes while we'll be talking. So what are blockchains? What are these two abstract components that that make blockchains blockchains, or that make us excited about this kind of technology? And in my opinion, there are two parts you really gotta understand that they exist and what the difference between those two are. So these two components is, number one, it's consensus, the consensus engine, the consensus algorithm. This piece of technology, this piece of software that allow us, the network, the nodes, the participants, to agree on what changes to include in a system that we interact in. And it allows us to come to a point where when we look at the system and we see some certain data or some state, some transactions or whatsoever, we are able to tell, hey, that's what everybody else sees too, and that's what we agree upon is the truth. And there are different engines and algorithms, right? You probably have heard about PBFT, you have heard about Algorand and a few other engines or consensus algorithms, and you've probably also heard about the kind of incentive mechanisms that provide us with information that we need in order to say like, hey, you know, we have an honest majority participating. Like we can assume a majority of participants in the system will behave honest. And that's where proof of work or proof of stake comes in. So this one part is a consensus part. The other part is the state machine. And the state machine is really, it's a part of the blockchain software that tells us what the software provides the user with, what the user can actually do in the system, right? So for example, in Bitcoin, I can transfer Bitcoins from one account to another. That's what Bitcoin was built for, and it does it very well, right? And whereas if you look at Ethereum, it's much more general, and it provides the user with a much more flexible and general scripting language that allows you, so to say, decentralized applications, right? Where you have some state that you can manipulate through transactions, right? And you come from a state, the current state that we have. Some user interacts with the blockchain by submitting transactions, so inputs data from the outside into the system, and the state transition allows you to come to a new state by combining the old state with the new transactions. And that can be, you can see that at very general, because transactions don't just have to be value transfer. They can be pretty much anything, as you've seen in Ethereum. But like overall, you have these two parts, right? Consensus and the state machine. And the consensus allows us to come to agree on what has happened in the state machine. So, when you look at what has happened over the last, since Bitcoin came out in 2009, 10, what has happened since then, right? We've seen that one size really doesn't fit at all, right? We have seen an explosion in the number of different systems, blockchain systems that have emerged. From Bitcoin over Ethereum to Zcash, to quite a few other systems that provide the user with very distinct functions of things that you can do within that system. And what we've seen that most of these projects actually don't differ in consensus that much. For example, if you take Bitcoin, Ethereum, or Zcash, right? But they're really distinctly different in the state machine. And that's what the user mostly cares about, right? The user wants the blockchain system to be secure, sure, right? But on the other hand, it wants different functionality to be provided with in different projects. And one area where we have seen particularly that these kind of needs of different projects can't be met by one protocol, by one state machine design, was in the enterprise space. Very simple example, right? The public blockchains that we have today don't meet the permissioning and confidentiality needs that enterprise have, and that again resulted in isolated private chains that try to alter state machines as we have them. And we as Parity have been involved in some of these enterprise projects, and there we have seen, hey, it's probably not going to be reasonable to assume that those are, for example, going to move on the public Ethereum blockchain if it even stays closely to where it is today. So in the end, what does that mean? Right, we have all these different projects launching new chains because they say like, hey, in Ethereum, for example, I can't easily add new cryptographic primitives. I can't easily implement RSA or whatsoever, right? So what do? I spin up my own chain. I build my own blockchain. But what do we end up with? We end up with a fragmented landscape with the same data silos that blockchain actually promised to break us out of, right? It promised to unite all these systems to be able to interact with, but we end up with the same silos. And that is where we believe interoperability, the need for interoperability stems from. These different blockchains, very different looking state machines, must be able to talk to each other. They must be able to communicate and interact. That is why we set out to build Polkadot. And it's a good question, what is interoperability, right? Like, it's a word of the day, it's a word of the month, a word of the year in the blockchain space. There have been quite a few projects now that have said like, hey, we built the new interoperability framework. But I believe some of these projects understand interoperability very differently. And here's what we understand under interoperability, or why we're looking at interoperability. For us, interoperability means to be able to connect chains with very distinct state machines. Very different looking state machines, and potentially even with providing their own consensus. It should support the past, the present, and the future. So the system we built, Polkadot, should be able, on one hand, to allow its constituent chains, so whatever is running within that network, to talk to existing blockchains. So blockchains that are running today, Ethereum, Bitcoin, and so forth. On one hand, it should really support the present as well. So whatever is being built right now, current day technology, such as, let's say, Tezos, or Dfinity potentially, once we know what it is, as well as the future. So we strongly believe that over the next 10 years, there will be new ways coming out, new technology that allows us to more efficiently come to consensus, new ways of doing governance, new cryptographic primitives. And like this framework that we're building with Polkadot should really be as open and flexible and able to annihilate this new technology as we go along. And even though we don't necessarily know what that will look like, right? And last but not least, the framework that we're building should allow public and private blockchain networks to run within that one network. And by that we mean it should be able to communicate, to access assets and data from one chain in another. No matter if one chain is more permissioned in the sense of, oh, it provides its own participants that validate transactions, and they are potentially 3 companies that come to consensus. Or if it's more a permissionless system that's based on proof of stake. And this is thinking beyond tokens. This is, in my opinion, a very crucial part, because other proposals in this space really focus mostly about interoperability of tokens. And that is clearly desirable, right? Think about a decentralized exchange, a chain which is able to have transfers from other chains, token transfers over to the decentralized exchange, and be able to provide that service to the user. But we think interoperability has to go way further. It has to provide all the constituent chains with the possibility to relay arbitrary data. And that again means, and that is very crucial, that one chain could potentially just call a contract, if we speak in Ethereum language, on another chain. So it can talk in whatever way it wants with another chain. It's not standardized up front. It's not limited to token transfer in that sense. So we have the interoperability part of Polkadot, right? Chains talking across the network, across Polkadot, across the relay chain to other chains. Another very crucial part of Polkadot is that we try to build something that allows all these chains to pool security. Because, right, connecting chains already, allowing arbitrary message passing is hard, right? But actually securing all of them in the same time and securing the messages is way harder. And why is that important? Why is it important to not only enable message relay, but also providing security as a service to constituent chains? Well, that point is pretty easily explained. If you look at the proof of work space, right, the number of blockchains that are out there right now, they all naturally compete for security resources. In the instance of proof of work, these resources are mining power, right, hashing power. So, and if you have one blockchain and you have all the mining power of the world, and all the mining power of the world is focused, pointed at this one blockchain, it's super secure. Now you have 10 blockchains, and this mining power splits up across these 10s. Each individual chain is less secure than before the one chain. And the same counts for proof of stake in general, right? Because it's a scarce, it's a limited resource, money. That's something that you can stake. So what we are doing in Polkadot is we are pooling these resources that can be used to secure the chain. So the Polkadot network, the relay chain as its umbrella chain, provides to all of its constituent chains consensus as a service, finalization as a service, and thereby securing all chains equally. I brought a little screenshot of 51% attack. I forgot the top level domain. It's a website that kind of lists what the theoretical cost of a 51% attack on a network would be. And it's frighteningly low if you look at the 1 hour attack. And that is one of the best points why we really need this pooled security. Imagine we provided interoperability between that chain, let's say here, down here, Bitcoin, where it costs to do a 51% attack for 1 hour, it costs only $500. And we connected it with Bitcoin. And there was some kind of payment on Bitcoin dependent on a smart contract that was running on Bitcoin, whatever Bitcoin is, right? So if that was going to happen, right, you could just attack Bitcoin, right, revert whatever transaction happens on there, and have the payment go through Bitcoin anyways. And that means, like, if you connect chains, right, it's only sensible if you have them all secured in the same way, because otherwise, the overall interaction, the overall chain of transaction is only as secure as its weakest link, which would be Bitcoin in that example. So, last but not least, if we manage to secure pool security, and if we manage to provide interoperability, a nice side effect that comes out of that is that we enable scalability in some sense. Because, right, we enable all these chains to execute transactions in parallel while being able to talk to each other. And Rob will go into a bit more detail about that later. Here's a high-level overview of the system, Polkadot. Right, we have the relay chain in the middle, the umbrella that connects, that relays all these transactions, and that provides security to all its constituent chains. And the constituent chains we call parachains because they run in parallel. And last but not least, there's a piece of technology we call bridges, and bridges really allow us to connect any and all chains in the Polkadot network to more independent chains such as Bitcoin currently, or Ethereum. So, now the last question I want to go into is, how do you build your own parachain? How do you build a chain for Polkadot, right? What's the easiest and fastest way? Well, that's where Substrate comes in. We build a tool, a framework, an SDK that allows you to build your own blockchain, whatever you want it to be, as fast and easy as possible. And this framework is called Substrate and provides you with a number of different things, right? So one thing you probably don't care about when you start a new project, when you want to build a new blockchain, is, for example, networking. You want it to work. You want the peer-to-peer layer to be proven, to be beta tested, and to provide all the functionality that you need. But you really shouldn't care about implementing it yourself. And there are a number of things, such as the nodes, the client software itself, the CLI, and so forth, that you don't want to care about. What you want to care about, again, is the state machine, the runtime, as we call it in that framework. And what we build Substrate based on our experience of building the Bitcoin client, the Ethereum client. We're looking into building a Zcash client on top of our Parity Bitcoin implementation right now. And we try to abstract everything and make it as easy as possible for developers to build their own blockchain. And we have a number of projects that are being built on Substrate right now. First and foremost, it's the Polkadot relay chain. So Polkadot itself, what is out there right now, what is being running in the testnet, is built on Substrate. But above and beyond that, Substrate is really the tool that you can leverage to build parachains for Polkadot. And while let's say, until Polkadot goes live in a year, mainnet goes live, you can still build your chain with Substrate and let it have its own means to come to consensus, right? We currently have a consensus engine called PBFT implemented. We soon will have another option for consensus, which Rob will be going into a bit more in detail. But basically, you build your Substrate chain now, and then in a year, when Polkadot goes live, you flip a switch and say, I want to be part of the Polkadot network. So here are a few examples of what else was built on Substrate. One of our wonderful colleagues, Wei Tang, in China built Shespa, so Ethereum 2.0. Whatever is spec'd out so far within less than 2 weeks on Substrate. And you can run it right now. You can run a dev tool right now. So because it's such a powerful tool that you can, in minimal time, you can build some very new, novel things, right? Here I included a few screenshots of what's running right now. If you go on telemetry.polkadot.io, you see 2 networks, right? One is a Polkadot testnet, the newest one called Chromalanke. You see 51 peers. It's humming along pretty nicely. There's another one called Barbecue Birch, which is also a chain built on Substrate, which is really Ethereum-like, but WASM-based next-generation smart contract blockchain, which could potentially in a year be part of the Polkadot network as well. And I would like to hand it over to Rob, my colleague. Thank you.
Yeah, big thanks to Björn for doing that awesome introduction onto interoperability in Polkadot. Basically telling us roughly what Polkadot is, interoperability. I'm going to go into that as well a little bit. Probably you might even see some of the same slides for the interoperability stuff. But I'm also, I have a clicker. So also I want to go into a couple other things. So interoperability is only one aspect of Polkadot. So one other thing I'd like to talk about is the fact that we've basically now reached the stage in the development lifecycle of Polkadot. It's been about 1 year since that initial distribution at the end of last year. We've been working really hard on actually developing this stuff and putting it together. It's at the stage where basically developers can start to build on it. I want to dive into what that looks like from a developer's perspective. And then go into things like governance, roadmap, where we are now, what's coming up next. But without right-clicking, we're going to go first into the design principles. So like, what were we thinking when we came up with Polkadot? So the first thing was that we want it to be heterogeneous. We want this to be an ecosystem of many different chains that do distinct things. Because our observation is that when you give freedom to platforms in terms of what kinds of computation they can do and also how they can store their data, you can get basically huge improvements in performance for transactions. So that's not even talking about things like algorithmic scaling solutions like sharding. That's simply just talking about execution of naive code. The other thing is we want it to be scalable. We want it to be scalable on-chain and off-chain with an ultra-efficient root layer. So we want it to be amenable for those chains to be themselves platforms for off-chain state channels or things like Plasma or off-chain settlement. And then we have an ultra-efficient root layer. And what I mean by that is the idea that every scaling solution has to execute transactions at some point when it resolves things on-chain. So the faster that you can make resolution of those sort of pinning transactions for off-chain stuff happen, the faster it's going to be, because that's going to be your bottleneck in the end. So if you can get 10 times whatever the root layer speed is with a scaling solution, that's fine, but you're still going to be bottlenecked by that root layer speed. And last, we really care that it's secure. So we want basically cryptographic proofs of things like consensus protocols. We want to use very hardened cryptography. We want game theory and incentives all to be aligned so that you can prove that rational actors will behave honestly, that we don't just assume oh, this guy will be nice and not attack the network, because we know that that's not how things work. So we really need things to be secure, and we model everything and find out if it comes out the way it should. So yeah, Polkadot has multiple chains running in parallel, so they're advanced sort of in lockstep, but each of those chains themselves can be very distinct. And we increase throughput by parallelizing transactions. So essentially, if each of those chains is running their own transactions, and we're splitting the workload of validating these chains between a group of people, then you can validate more transactions simply by nature of validating more chains at once. It does sort of push the problem onto like a data availability layer, which I'll get to a bit later in the talk, how we sort of address that, but it gives you like a quadratic improvement in scalability just with this architecture. So yeah, the idea behind interoperability is to connect chains with distinct state machines that do vastly different things to support, as Björn said, the past, the present, and the future. What has been built, what people are talking about now, and the stuff in the future. And this is a really key point because, I mean, if we knew what kind of stuff people were going to build 5 years from now or 10 years from now, we would be building that, like no question. But we don't. So we have to build a system that's upgradable in a way that like whatever comes along, we can integrate that. And there's sort of two ways we do that in Polkadot. The first is simply by virtue of the extensible nature of parachains, where if something new comes along, you just add a new parachain that implements that thing. The other way we do it is through the governance mechanism of Polkadot, which allows for on-chain upgrades of the Polkadot logic itself. So this blockchain is dynamic, and I'll talk about that a bit more in the future, as in maybe 10 slides from now. And public and private running in the same network. So connecting blockchains is really hard. Blockchains compete with each other over resources right now as long as they're not in the same sort of section for security. There's this diagram you saw already. On one side, they're competing. On the other side, it's shared security. And I want to delve in to an example of really what it means to have one chain being insecure when other chains depend on it. So like you have chains depending on actions caused by other chains. So we see everything has a price. So when we talk about proof of stake and finality and consensus and those sorts of things, we're just saying with those amounts of people staked, you would have to buy up 1/3 of them or 1/2 of them, depending on like your network assumptions, in order to overthrow that chain. It's the same thing with proof of work. You never get absolute finality because the actors in the system can always be bought for some price. So if you have one chain which is vastly weaker, like $3 million of security, versus one with $10 million, and we have a cause coming from the chain with $3 million, and an effect occurring on the chain with $10 million of security, you can do a much cheaper attack on that $3 million chain, revert the block that had the cause. So if you look at this first chain, cause of a transfer didn't happen. So like the money that was sent was never sent from the point of view of this chain, whereas the effect still occurred on the other chain. This is basically the crux of the issue with pooled security. So to talk a bit now about some paradigms of interoperability, once we have understood that issue a bit better, one thing that we really want to do is things like cross-chain smart contract calls. So you have, and this wouldn't necessarily actually be smart contracts, it's basically just an interface for computation, an interface for dealing with aspects of one chain from another chain. So in Polkadot, the abstraction that we expose is chains can send arbitrary data amongst themselves. But this will still require some kind of standards and formalization where certain message formats are expected by one chain. Like for example, if you had a smart contracts chain, it would expect the messages that it received to look something like smart contract calls, the call data in the format that it expects. So we have a chain with a break-in contract, and that would be specialized for the chain, that is called whenever messages are received by that chain. And it can interpret the message received by it. So we have a chain sending a message to chain A, and then chain A's break-in contract interprets it as a sub-call to another contract. And this can also, send a receipt, and we can have acknowledgements and that sort of thing. And this will end up being actually a really powerful tool because we can do lots of computation on one chain with just a single trigger from a first one. Another example of what we can do with interoperability would be something like a bank chain run by a consortium. So we've talked about Polkadot as a system that deals with state transitions. But we haven't talked about what those state transitions are. So here's an example of one, which might be interesting for those trying to integrate public and private. We have a chain that's secured by a consortium, and the state transition is simply that, some state changed. We don't justify it by actually executing any code. The only way we justify it is with digital signatures by the members of that consortium. So when Polkadot evaluates, is this block good? It's just checking, was it signed by the right people? So that means that it can receive messages, but it doesn't have to justify like what it did when those messages are received. It can do balance transfers, but it doesn't have to justify which accounts had balances transferred, although it could prove that if it wanted to. And outgoing and incoming messages, all of them are handled completely opaquely. So this allows actually somewhat transparent interoperability of a private consortium chain with public chains, simply because it adheres to the interface of the Polkadot network, but the actual computation that this chain is doing is obscured by the consortium that runs it. So now to dive in a bit to what Polkadot means for developers, like as a dev team, what does it take to actually start to build on Polkadot? So Björn went into this a little bit before. We have two sides of a blockchain. One side is the state machine, and the other side is the consensus. So the state machine is kind of like, what does the blockchain do? Does it transfer money? Does it coordinate file storage? Does it do smart contract computation? Does it do zero-knowledge proofs? It does the cool stuff. Consensus is just, how do you provide security for that? And right now, everybody developing a blockchain is doing both of those things. Whereas really, you have a lot of projects where the only innovation that they have is in their state machine. So what Polkadot enables is for developers really only to have to think about their state machine, because consensus is already provided for them by the Polkadot network. So when we build a parachain, we're probably using these three technologies. One is the Rust programming language. It's safe, secure, efficient. It categorically eliminates various security flaws that have taken down browsers and banking applications and all sorts of things, but it doesn't sacrifice any performance to do so. WebAssembly is the language which parachains are actually compiled down to. It's like a very low-level language, virtual machine, which is designed to be extremely efficient. And one reason that we really believe in WebAssembly is the fact that it's been backed by all major browser providers. So you have Google and you have Mozilla, and they have huge amounts of money and huge amounts of effort going into WebAssembly, which was originally intended to replace JavaScript, like that you can write code that compiles onto WebAssembly and just get rid of JavaScript, run a website that uses WebAssembly. But we've seen that actually it's designed to be fast, it's designed to be very low level, it's designed to be secure. It's also very applicable to the blockchain space. The other thing that we're using is libp2p. So that's something spec'd out by Protocol Labs, IPFS, IPLD, those sorts of things. And libp2p is just a protocol for peer-to-peer networking, how you build these decentralized networks of nodes talking to and discovering each other. So to explain how a parachain fits in with those technologies, a parachain consists of a validity function. The validity function is simply WebAssembly code that is executed every time you have a block. So you have the last block which was agreed upon, and you want to add a new block. You need to provide the new block as well as a proof of its validity to Polkadot. And then Polkadot can execute this validity function to see, is your proof good? So the cool thing about this is that proofs can be something like a subset of a Merkle tree of accounts, the way that Ethereum works. It could also be a zero-knowledge proof. It could be anything. We also have a collator node. So a collator node actually does this job of creating the candidate blocks that satisfy the validity function. So this is sort of akin to something like a miner or a consensus participant in current blockchains. So you have a miner sitting around that accepts transactions in its queue. and then it does a bit of work, it proves the validity of that block and sends it around the network. So we have collators for specific parachains who sit around, accept transactions in their queue, create a new block, and create a proof that that block is valid that satisfies that validity function. And the last thing that you need from the perspective of a developer is to understand that there are message queues. So Polkadot has a message queue of incoming messages to your parachain at every block and outgoing messages from every block. So at a 10,000-foot view, we have these three pieces. The relay chain coordinates consensus and transaction delivery. Parachains are their own constituent blockchains, which have their own logic and own validity constraints. And then lastly, we have bridges. Bridges are actually themselves parachains. It's just a parachain whose validity function is designed to interpret the behavior of some other chain. But you can fundamentally treat it as something else. So we talked a bit about Parity substrate, but I'd like to give a bit of background on where this came from. So with Polkadot, we're working with the Parity dev team to create this first implementation of the node. And the Parity team is one that, at this point, actually has years of building blockchain nodes, years of experience in building blockchain nodes, which is actually something very rare. I've worked with them in the past, have built a Ethereum node, have also built a Bitcoin node, have built light clients, retrofitted them onto things, have designed sync solutions like Warp Sync, done experimentation and consensus algorithms. And when we started to write Polkadot, we basically said, look, we're doing it all again. We should just turn this into a library. We've done this 3 or 4 times now. We can turn this into a framework and just distribute that and make it open source, because everything we do is open source. So that's sort of the origin of Substrate. But Substrate, sort of as a future thing, will be sort of a bigger piece than that, because Substrate sort of gives you all those pieces like a database and networking and synchronization of the chain for free. So when we talk about people writing parachains that are WebAssembly, it's that's a difficult concept. It's like you give that to a developer and they're like, okay, sure, but where do we begin? And if you just hand them Substrate, you can say, look, you can build it in 2 minutes. We built a parachain, a test parachain in 200 lines of code using Substrate. So I mean, this stack is roughly how Substrate works. So at the core, we have a runtime, which is something like this WebAssembly validity function. Then outside of that, we have consensus, which provides agreement on the WebAssembly code that's been executed. And then we have a networking layer on top of that. So WebAssembly, it's fast, but it's not as fast as running Rust or C or C++ code that's been compiled down to native. So we can employ a trick for optimization, which is essentially that we would keep around on the node some version of native code, which we know to correspond to some specific WebAssembly code. So if the code of the chain hasn't changed, we can just execute the native code and not execute the WebAssembly. And that's an optimization because the code of the chain is unlikely to change very frequently. So we can always get native speed, but in the case that the code of the chain is upgraded, we can always execute that WebAssembly and get the same result. And that's a really powerful tool because if you tried to run a blockchain where every transaction was executed in a WebAssembly layer, especially if you had to execute something like an EVM or some other virtual machine inside of it, then you had a virtual machine running inside of a virtual machine, and that just means slow. We don't want slow blockchains. We want fast blockchains. Yeah. So what Polkadot for developers really looks like is you have an extremely simple API. You basically have this one function you have to implement, execute a state transition, get the last chain head, a proof that the new block is valid, and take some messages in. And if it's good, you return some new chain head data and the messages that are coming out of the chain. WebAssembly will give you the power of a familiar language like C or C++ or Rust, because you can literally write these languages that you're familiar in. Now, the paradigm of programming for smart contracts and programming for blockchains is a bit different than writing code for regular systems, simply because you have sort of global storage You have a lot of data, like account balances, that have to persist between executions of the function, of the program. So it takes a slightly different approach to do this correctly. For that reason, we've been working on what we call an embedded domain-specific language, which is a sort of modification of Rust to turn it into something that's completely suited for writing blockchains in. So you don't actually even have to worry about the like weirdness when you try to write for blockchains in a language that was not designed for blockchains. At the same time, you don't have to deal with these languages like Solidity, which were sure designed for blockchains, but also just don't have the developers looking at them to make sure that they're up to scratch and that they're secure. Rather, you use languages with decades of support that are backed by compilers like LLVM and that can get huge amounts of performance and provide ease of use and have communities behind them that give you development tools that are actually pleasant to work in, which is hugely important for productivity. And as far as writing a collator node goes, like you will get this basically for free from Substrate. This is actually a really interesting point because it means that you could just write some blockchain in Substrate. You don't even have to think about integrating it into Polkadot. You just write your Substrate chain. Like, oh, I want to write a chain that does this. And Substrate would give you the consensus algorithm and everything for free. But if you wanted to, you could basically just flip a switch and make a version of that chain that runs on Polkadot, which is really powerful because you can have teams that are prototyping while Polkadot is in a development phase, or teams that are writing something already, and then when Polkadot is more ready, they can just flip a switch and it'll be something that runs on Polkadot. There's an analogy that I've heard used, which is that a Substrate chain is something like a computer. Like what you actually care about is the computer that you're using, whereas Polkadot, when you add that in, is like a network card. So you don't really think about like what the network card does, but it connects you to all these other blockchains. It connects you to the rest of the internet. Whereas what people really care about is like the computer and what they can do on that. So from a developer's perspective, like Polkadot is not particularly interesting. It doesn't get in the way. What they care about is really more about Substrate and writing their state transition. So now just to pivot a little bit and talk about our consensus algorithm, because it's pretty cool. We want to have a very low barrier to entry, that it's cheap to become a validator. Like we don't want to get in this situation where you have like, I don't know, 21 block producers who go in a Skype call and decide things. We want there to be thousands of validators who, like anybody can join. Someone like, probably your grandma isn't going to become a validator, but if you have sysadmin experience, you could reasonably spin up a node and find the fee to become a validator and produce blocks. We also have this notion of a hybrid consensus algorithm. So what we mean by that is separating the aspect of producing blocks from finalizing blocks. And also to make use of the blockchain structure. So what I mean by that is that when we're voting on blocks, that we apply those votes to blocks before them. Because if you vote on block X, you're saying, oh, the block that came before X is also valid, and the block that came before that as well. So our block production is going to be round-based, probabilistically safe, something like Nakamoto consensus, with a large pool of validators and authors aware shortly before their turn. The finality gadget is this thing that I was talking about. I'll skip to a diagram where you have like a small, focused, highly staked pool, but essentially validators are voting on the best chain that they've seen, and it figures out the common ancestor where 2/3 have seen that block. So even though we've got like a small fork here, it can figure out which block everybody has seen and finalize that and prove that it's never going to be reverted without half of these guys getting their money slashed. That is something that's implemented. It's something that's spec'd out and proven. It's going to be the next release of Polkadot. To speak a little bit about governance, our key idea there is upgradability, so that we don't know what's going to happen in 5 years or 10 years, but we want to be able to support it. So we want to have a process where we can actually have many different metrics for determining what the community supports, things like identity-based quadratic voting, hash power voting, which is essentially proof of work, but just in a governance context, coin voting that's skewed based on turnout, that sort of thing, to basically make these decisions for when the chain can be upgraded. And this is upgrades without hard forks. We've actually done one of those already from the proof of concept 1 chain to the proof of concept 2 chain. And it's a tool that we expect to be leveraged as new cryptographic primitives come out, stuff gets broken, et cetera. And one thing to note is that the governance process is itself self-upgrading. So you can have one governance process defined now, but it can change itself in the future and redefine that process. So as the technology gets more stable and less nascent, you can make it more restrictive. So just quickly taking inventory of where we are. We did POC 1, which was the initial governance system, staking, basic user interface, forkless upgrades. POC 2 was actually the implementation of that parachains thing, except without communication between them, so scalability without interoperability, and a basic light client. Did the first dynamic upgrade. POC 3 is this consensus thing, which I talked about before. It's something that's designed to tolerate huge partitions in network connectivity. So for example, if you had like a network split where half the validators could talk to each other and half the validators could talk to each other, once that resolved, even if millions of blocks had been made, we could finalize them instantly. Then what's following next? So next up will be the proof of concept 4. That'll be interchain messaging. That's the actual interoperability aspect. And from this point, which we expect to be basically by the end of this year, this is more or less complete for developers, modulo some nice developer tools. Like this is the point where, as a developer, almost all work on Polkadot beyond that point is just going to be modeling and tweaking parameters and implementing some game theoretic stuff as seen in POC 5. But the actual interfaces that a developer expects are not going to change really from the end of this year. And that's when you can actually get teams that start to build on it. Yeah, in parallel, we'll be working on those developer tools. So making Substrate really, really suitable for building Polkadot parachains.
I would suggest we do a quick Q&A, so to answer any and all of your questions while I show you a bit what's available online.
Yeah, so the question was to repeat sort of that process of avoiding WebAssembly as an optimization. So the way that works is we have some, like when we compiled the state transition to WebAssembly, we have some code that implements that state transition. So at that point, we can compile it either to WebAssembly or native. So if we have a specific piece of WebAssembly and we're aware that we have the native version of that code corresponding to it, we can always just execute the native and get the same result. As long as the block producers are executing in WASM, we can check those computations in native code, and even if there's mismatches, the chain will still function. So this is specifically because, so it's not something you have to worry about unless you have a dynamically upgrading chain. If you have a dynamically upgrading chain like Polkadot, where the code of the chain is stored within the chain as WebAssembly code, you know that this is not going to change more than like once a year or something like that, twice a year with planned upgrades. So if you have every node deployed with a version of the native code that does exactly the same thing as the state transition of the blockchain, you can execute things really fast. But even if you do upgrade something, it means that you don't have to distribute a new version of the node to all clients who use it.
Do Collider nodes need dot tokens?
No.
Okay. How would you build like a relay bridge without the tokens?
So a bridge between chains. So to bond a parachain, so to attach a parachain to the Polkadot network, you actually do need to lock up some dots most likely. But collators are strictly defined in terms of like they send a proof to some validator, and if that proof is good, the validator will probably share a portion of the block reward with them. But building a bridge itself is really more about writing a parachain which knows how to evaluate the consensus mechanism of some other chain. It doesn't require dots. However, if you do want to send transactions between those chains, those transactions would need to encode dots of some kind. Could we run a parachain separately and do the consensus on Ethereum? Yeah, that's part of the goal of bridging to chains like Ethereum, is that like we want to leave that open to farm out computation to Ethereum or still have a network effect with applications built on Ethereum. Parachains as attached are always going to be under the Polkadot consensus algorithm, just as defined. However, you can link to the Ethereum chain, and any computation that you have done over there will be under Ethereum's consensus. So the question was about, given the parity multisig issues, whether sacrifices have had to be made in the roadmap. And the answer to that is frankly no. So a lot of that money raised by the Web3 Foundation was intended to be apportioned to things like PhD grants and funding ecosystem projects and that sort of thing. Whereas the amount that the Polkadot core team needs to build the initial version of mainnet was actually not shipped into by what was taken. So basically what's really been lost there is like ecosystem grants and research and funding other projects like Whisper and mesh networks and that sort of thing.
I touched earlier on telemetry.polkadot.io. You have two networks right now, the Polkadot POC2 test network, where you see a bunch of nodes, where they're from, what is happening. You get a bunch of nice stats, a map, and so forth, can play around with that, as well as Barbecue Bilge, which is the smart contract, wasn't smart contract chain that I was talking about, also testnet. Spin up your node, just go on the GitHub substrate page or the Polkadot page, download the stack and just run it, and it will automatically support to connect to telemetry. As well, we have a UI online, poc2.polkadot.io, where you have a simple block explorer. You can inspect blocks, see what's happening, what kind of validators have done what justifications. You can do transfers. Here we can transfer everything from Lehman Brothers to the bin, I guess. Or validator 1, or you can go on staking. You get a staking overview. Here we have 22 validators of 22, different intentions, session lengths. You can see all what's up, what validators were currently running, which are going to be in the next round, and so forth. You have a democracy module, which really depicts our governance currently, where you could potentially upload a proposal currently, how Polkadot should evolve, and then other people could vote in a referendum what's going to happen with this proposal. Can create accounts, create accounts, addresses, inspect the chain state. For example, you can check what's the timestamp right now within the chain. You could, for example, check in staking. Oh yeah, what is the bondage of validator 1? And we check that out. Or can look what is the bonding duration. So there's a lot of nice things you can do. Extrinsics is what you know from transactions kind of in Ethereum. As like here, you can interact with the blockchain. I could interact from this account. Say like I want to do a transfer to a certain recipient and transfer that many tokens here. Submit. They would ask me for my password. And it's gone. So, and yeah. So Lehman Brothers just lost all of its money. And then we have Vanity and a few other services you should check out if you're interested. And the nicest thing, obviously, these tools are available for any project that you build on Substrate, right? Because like all these modules that you see here interacting with, like democracy, staking, are all one-time modules that we give you for free within the Substrate framework. We currently use it and further develop it for Polkadot, but you could use it for any and all of your projects that you build on Substrate. It's pretty nice, I think.
My name is Jake Brukhman. I'm very excited to be here. Thank you for to the Web3 Foundation for hosting this. Very excited to give this talk. This is the first talk where I'm kind of collecting my thoughts around this concept of generalized mining and the third-party economy. I'm the managing director and founder of CoinFund, which is a crypto fund. just a little bit about us. We've been a crypto fund since July 1st, 2015. And many of our partners have been in the space even longer than that. Today we have a multidisciplinary team of about 9 people and studying kind of all aspects of decentralization technologies, from consensus to crypto economic systems to the kind of financial deals that are going on in the space. This year we launched our second fund in partnership with Venrock and David Pakman. And Venrock is an anchor and platform partner with us. I would summarize by saying we're kind of full stack investors across all crypto economic systems and their rails, which might include centralized companies or key financial infrastructure, helping more traditional money kind of get into the space, and also financial services around blockchain. And most importantly to this talk, we're active participants in decentralized networks. So I want to start off with kind of a philosophical point before getting to the point, which is that decentralized networks are not companies. It's very easy to, I think, confuse them with companies in our moment in time when most of these projects are very nascent. The focus is very much on early stage teams. The focus is on funding rounds by VCs out of Silicon Valley, and everyone's slicing up kind of token supplies as if they were shares of equity. But what we really want to get to is to try to understand how this kind of plays out and what decentralized networks mean in the long term. And there's just a few people who've been able to verbalize this very well. One of them is here, Jacob. He says in his article, "Blockchains are not startups," it says, "Blockchains are better understood as institutional technology, expanding the possibilities of economic coordination on the web." And another group out of Australia doing some economics research around blockchain governance have also described it as institutional technologies which produce public goods. And sort of the larger point here is that as these networks grow, they become public, globally accessible, and in some cases, like decentralized storage networks, they might grow larger than most of the storage providers that we know today, maybe combined. And so to understand generalized mining and what this means, which I'm going to explain, we do have to have a thesis or make an assumption about how the world will develop. That assumption is that decentralized networks will proliferate and become ubiquitous public utilities. If you believe that Bitcoin is going to be the only network, this talk is not for you. But if you're a fan of Polkadot, then this talk is very much for you, because Polkadot kind of envisions that world, right? Like, in the sense that a number of chains will coexist, they will interoperate, and they will optimize for kind of different use cases. So decentralized networks are kind of developing, right? So we maybe first saw decentralized networks in the context of Napster or peer-to-peer file sharing, and then in the blockchain context, we started to think about it in terms of, at first, cryptocurrencies. In 2015, we also had these kind of asset issuance platforms like Counterparty or BitShares. And then, of course, Ethereum went into production in 2015 as a smart contract platform. This is very low-level technology, very base layer technology. And when we get to 2018, things start to get quite a bit more interesting. We see resource networks. So these are networks that are providing decentralized storage as well as decentralized computation. We see networks around content. So if you're familiar with Steemit, this is kind of a decentralized social media network built on top of a blockchain. And the core kind of business units in that network are blog posts or news. We're now also starting to see various kinds of financial services networks. I'm thinking prediction market platforms. I'm thinking lending platforms. Some of these have dedicated networks as well. And registries, things like Handshake, right? Registries for DNS, and things that, like, if you really think about, really should be kind of a public utility network governed by kind of all of the collective owners of that network. So the interesting thing about decentralized networks is that they need participants and they need services to function. So these are not like monolithic companies or organizations. They actually need to go out and find third parties that make them work, and we're going to dive into that in this talk. Maybe we'll start at the beginning. So if you think about proof of work systems like Bitcoin, this started with a fairly straightforward set of participants and service providers. Users put in transactions and move Bitcoin around, and then miners collectively process those transactions, and the emergent phenomenon of that is the network. And then you all get Bitcoin and you hodl it. When you go over into proof of stake systems, then miners become validators. It's not quite a mining thing anymore, so we call it something different. Still have users putting in transactions. Now you have this new participant type called delegators or stakers, right? And these are, these may be users, but they equally may be speculators or investors who are trying to make a return on the stake by providing the service of kind of voting on validators and security in the network. Going over to a content network like Steemit, you have witnesses, which is the Steam version of validators. You have folks writing content and publishing it. Those are the content creators. And in Steemit in particular, Steemit relies on content curators to bring the best content to the top. Typically, that's done by users, but more recently, that's done by automated bots. And this is actually very interesting because if you think about the interplay of automated curators and everybody else, this is kind of an advertiser service, right? You pay these bots some asset. They use their influence in the network to vote you up and get your content higher, and then you get an ROI. This is very similar to what is done in advertising when you pay Facebook to get your stuff out. Polkadot has a participant type called fisherman. I guess the point I'm trying to make here is that this is a very interesting participant type that is specific to this network and to what this network is trying to do. And what fishermen do is they basically submit proofs of misbehavior to validators to punish people and thus provide for some of the security of the network. Not to belabor the point, but if you go over to layer 2 in the state channel space, again, you have, this is a very cutting edge technology space right now, and nothing is even set in stone, but various kinds of network participants operate on layer 2 in order to ensure liquidity, in order to ensure that as you transact, if you go online, you're actually saving your state in layer 2, that you're routing orders correctly, you're resolving disputes. Not to belabor the point, but if you're in the live peer network, out of the gate, there's 5 participant types. You had kind of the seed investors that help to bootstrap the project, users who should be streaming and transcoding video. Very early stage in live peer today, it's not happening too much. You have delegators in the same way that you have delegators in other staking networks. You have transcoder nodes that are actually transcoding the video and helping to stream. And then, very interestingly, and this just concluded a couple of days ago, the Merkle mine in live peer. If you know, how many people heard of the Merkle mine? Nice. So for anyone who doesn't know, this is a crypto economic system that incentivizes third parties to perform the airdrop of 63% of the live peer token supply for free to eligible Ethereum addresses. A very interesting system where basically the cost of doing that has been delegated to these third parties who are performing this very valuable service for the network. And if you've been to the recent community call at LivePeer, there's now a proposal for orchestrators, which are software nodes that control what would be kind of dumb transcoder nodes, hardware nodes. Furthermore, you can think about what happens when LivePeer becomes an actually utilized network. You have a lot of people streaming video. Maybe there should be some transparency around what video is being streamed. And so you can imagine yet another participant type providing transparency to that and saying, and maybe flagging videos that are infringing on jurisdictional laws or anything else. So here you have an example with 7 potential participant types. So in summary, decentralized networks need hardware to provision the network. They need software to secure the network. They need stakers and people engaged in a governance process to govern the network. And actually a really long list of supply-side services that are provided by third parties in order to make these networks function within their particular business domain. Again, this is the kind of, if you were to like roughly try to characterize this, if you're like really low in the stack, you might be processing transactions, you might be computing smart contract outputs, et cetera. If you're in a network like Filecoin or LivePeer, transcoding video, right, you're providing computational resources or storage resources. If you're in a Steemit or a decentralized Twitter or any other content network, you might be providing the service of curation. In the more financial services applications, like if you think about Augur, right? Augur has obvious, in the case where it is highly utilized, like it has obvious needs for liquidity in its markets. You don't necessarily want to wait for a long time for that market to resolve. You might be willing to pay a fee to a market maker to get your money out of that market sooner. And furthermore, you need markets in the first place, right? There's kind of an opportunity there to provision markets, and maybe you're using a machine learning algorithm to anticipate which markets are going to be popular. If you're the best at doing that, then you stand to make a return. And a whole slew of miscellaneous zoological, cryptoeconomic mechanisms. If you're familiar with FOMO 3D, not that this is so much a useful service, but certainly illustrative of how cryptoeconomic systems could work. And someone did make on the order of $10 million in engaging that mechanism. So all of this stuff, all of these supply-side services, I've collectively grouped under this term that I've been using, generalized mining. But of course, mining 2.0 has been used, supply-side services or network service provision. In fact, there's a whole thread on Twitter about what this should be named. And the set of opportunities around generalized mining, I think, can be described by the phrase the third-party economy. And so the two key questions that that we're at CoinFund trying to answer is, like, first of all, if this is true and if decentralized networks are going to be ubiquitous and providing all these kinds of different services, how do you make sense of that opportunity space? Like, how do you characterize it? And number two, what is the role of the crypto investor or the crypto fund within that space? Given the fact that you have a world with miners already, as well as a number of companies that are engaging specifically in staking, as well as funds who want to participate. So I'll tell you how I characterize it and how I make sense of it. So this diagram tries to, on the x-axis, take like the opportunity set and sort of say like how much hardware is required, how much software is required. So all the way on this side, you might have something like proof of work mining, right? This is something that has a lot of commodity hardware. You're running a $100 million data center, but relatively little proprietary software. Maybe there's some software controlling your data center. Maybe you wrote it yourself, maybe not. Maybe somewhere in the middle, you have something like Cosmos, right? Cosmos is not something that you're going to be writing a lot of proprietary software for. You have the node being provided to you by the project, but you might in order to create a better security setup in Cosmos. On the hardware side in Cosmos, you don't need a lot of hardware, but in that network there's a lot of emphasis on physical security of your hardware. And so the cost of it, is not as expensive as running a $100 million data center, but is not as cheap as running an AWS commodity node. And all the way on the right side here, you have something like the Merkle mine. And this is something that requires a lot of proprietary software and relatively little hardware. So if you characterize it this way, and of course this is a little bit of an oversimplification, but on this side you have things that are very hardware intensive. On this side you have things that are very software intensive, and here you have this kind of staking space of maybe mixed strategies where you're doing a little bit of software, a little bit of hardware. And this is interesting because this allows you to break up the space in the following way. Well, what are you competing on here? You're kind of competing on how much computer power or hash power you can aggregate. And so you're kind of competing on how capitalized or rich I am. And on this side, you're competing very much like a quant trader. How smart am I? If I'm the guy who can write the best proprietary algorithm, then I stand to generate the best return. And here in the middle is probably where most staking stuff will end up, and this is about efficiency. This is probably the area that's going to get very commoditized. In fact, we at CoinFund have already talked to a number of companies whose product is one-click deployment of staking nodes, right? And so this is about how fast can I get onto these networks? How efficiently can I get onto the networks? And competing on really like efficiency more than capital. And so if you believe this diagram, then you can kind of see that from this side you're going to have maybe funds and maybe quantitative traders coming in and trying to exploit like the proprietary software opportunities. Here, a number of traditional mining firms that already have big data centers could repurpose their hardware for different networks. And if they have GPU data centers, they could, for example, transcode live peer videos using that hardware. And here is where most of our staking companies are kind of coming in, and they're thinking about Cosmos, they're thinking about Tezos. They're thinking about those opportunities where it's important to learn the crypto economics, but not so important to write a lot of software for that. And the next slide I kind of put in here because to me, when I think about this space, staking really represents almost a minority of the opportunity that's possible. And even within staking, if you're just a company that's building a staking, or a business, I should say, on the staking model, it's important to note that not all staking networks have this property of delegation. And so if you're a company that's building your business on the idea of taking commission from these staking operations, then you might not be able to go kind of outside of that circle. So this is cool because crypto funds and crypto investors can become active network participants. They might want to do this because that's a competitive advantage. If I have a large stake in a network and I can stake it and earn a 20% return on that stake, that's great for my investors. And if other funds are doing that, I might have a competitive pressure to do that. At CoinFund, in our live peer case study, we showed that using transcoding and mining, we could build up a pretty significant stake in the live peer token supply without ever having been an early kind of SAF node investor, just coming in at the point where the network is functional, using technical acumen to build up that stake. And as an investor participating in networks, you're actually adding value to those networks. You might be adding liquidity to like a layer 2. You might be putting your brand behind that network, but you're doing it in a way that's highly accretive and useful to the network. What really gets me excited is when crypto funds and crypto investors must become active participants. And I'll give you an example of how that might happen. In 2015, a lot of VCs, saw people building the early decentralized networks, and they invested in their equity. But then it turned out that all of the value accrued in the tokens of the network. And so, In 2016 and 2017, a lot of these funds rewrote their LPAs to invest in tokens, to invest in crypto hedge funds of all things. Very unusual, just so they can get that exposure. And now when you go to layer 2, if you look at the landscape of the layer 2 projects, most of them don't have tokens. Half of them are open source. There's 3 token models out of 16 projects or something like that. There's not a lot of opportunities to invest in tokens or equity. And so how do you, if you believe that layer 2 is the short to medium term scalability solution of Ethereum, how do you as an investor get exposure to that? And the answer is that you run a hub on the network and add value to that network. Here are some examples of funds and other companies that have been doing this kind of work. At CoinFund, we have Steam curation running, live peer transcoding and mining completed as a case study, and kind of looking at layer 2, Cosmos, a number of other networks. And a number of other funds have sort of picked this up. You know, just yesterday, Fabric Ventures announced kind of Ocean protocol integration, Multicoin's going out with an EOS block producer, and so on and so forth. I think Figment Capital is here. I think you guys do Tezos as well, right? And so my conclusion is that this might be an end state of the world. We'll see. And in my opinion, in that world, investors are going to have to get a lot more technical about participating in networks. And if you're a pure VC, you're going to get really constrained in that area of equity if you can't do that. And participate in your networks. If you're an investor, if you're a user, add value to your network that you partially own by engaging in staking and maybe providing services if you're a technologist. Thank you. Any questions? Yes, sir. I think you should. I mean, I think like all these are experiments, right? And different levels of maybe if you want to call it Gini equality in networks are interesting things to experiment with. You know, when I a lot of people say like, well, how can Bitcoin be a democratizing technology if you look at the Gini coefficient of the Bitcoin distribution? And my answer to that is like, well, you know, that's true, but at the early stages of the network, the opportunity to be one of those large holders was very widely accessible. And so if you didn't get a chance to be one of those large holders on Bitcoin, you actually might get a chance to be one of those large holders on a network that comes after. And then if you measure your Gini coefficient kind of across networks thereafter, I think you'll find that you have a much more equitable distribution on average per person, like across networks. Yeah. That may or may not be true, though, right? So it I mean, I think if you fuck up the network of a portfolio company, it's not going to turn out to be a good investment, right? It's an interesting point to think about. I think there's a lot of like approaches, you know, you can take, but I would say like in general, if the crypto economics of a network is designed well, then it's going to be secure against sort of those kinds of drastic attacks. If it's not secure, then your action of doing an attack like that on the network maybe is beneficial in the sense that the network will then fix, you know, that issue, potentially. Yes. Hi. I vaguely read the article. I think actually it's funny, like, because Union Square, very much did a lot of like low stack and infrastructure kind of investments. So it's a little bit funny that they're now going to apps. But of course, they're also invested in CryptoKitties, which is very much an app. My answer in general is that is Augur an app or a protocol? Well, it's like kind of both. And then you can build stuff on top, and those things could be protocols, they could be apps. So I think like the line between like apps and protocols is not like fully clear. And Steemit is very much looks like an app. And I think we'll see a lot more applications as time goes on.
Last talk is Patrick, and he's going to give a quick overview of what he's doing with Clovyr. So the last talk Patrick gave was at our meetup in San Francisco, and everyone said, hey, that was the best talk. So yeah, excited to have him back in New York.
Hey, everyone. Well, stage is set. So I'm Patrick. I've co-founded a company called Clovyr with Amber Bolday, and we totally agree with what was just said, that there's a huge focus on infrastructure and not the applications. But also that the line kind of blurs, especially when it comes to Polkadot and Substrate. Like, it's not really clear what's an app and what's the protocol, but what is clear is that it needs to be easy to build whatever is the app, or people aren't going to do it, and none of what we're doing here is going to matter. So who volunteers to define clearly the different terms for what we're doing here and describe the differences between each of these things? Any volunteers? DWeb, Web 3.0, dApps, replicated state machines, Web 3 without the .0, peer-to-peer. No? Nobody? Okay, so well, just before we get to the definitions, they're all kind of popular, and none of them in particular is taking off compared to the others. So there's a lot of kind of noise around what we're even talking about in the first place. And the definitions, as according to somebody who was not primarily pitching blockchain in the first place, Brewster Kahle from the Internet Archive, his definition was that it's, and he defined kind of the distributed web or the decentralized web, and based it on Tim Berners-Lee's definition. He said it's peer-to-peer based, it's private, so you can't be tracked, it allows you to authenticate without centralized usernames and passwords, and it has versioning. Notice he didn't say like immutable record or blockchain. He said content is versioned so you can see past revisions. Easy mechanisms for readers to pay writers, so content creators can get paid without having to show ads. And he put a special emphasis on fun, which is kind of curious. Take Blockstack's definition. People control their own identity, their data, and they have privacy and security. And the blockchain is what kind of ensures consistency of the whole system. The Web3 Foundation defines it as an internet without servers. People own their data, identity, and destiny. And Gavin Wood had a similar definition. He says everything should be based on kind of this global file system, and everything is articulated through this file system, and everyone has the same view into it. And then the actions that are performed on it are all ordered on a blockchain. And he had a kind of an interesting addition to this, that the blockchain is what allows you to create kind of a global reputation system, because according to him, it's important that if you do something bad in one area, you can get kicked out of the whole network. So that's kind of an interesting definition. So here's an interesting point. What I showed you before was the zoomed in version of this. This is the zoomed out. So can anyone tell me what 10 years ago Web3 was? Because it wasn't blockchain. All right, so there was something called semantic web. Anyone remember semantic web? Yeah? Tim Berners-Lee and many other people defined it as a fully distributed web-based systems for publishing logical assertions. Does that sound familiar? If you remember, if you were making websites a long time ago, if you remember there was, and you wanted to get your content on Facebook, you wanted people to be able to link to your website, there was the bad way and the good way to do it. The bad way was to just make a website and hope people link to it, and the good way was to conform to what Facebook wanted and put tags in the source code for your website so that it would actually show your video or the right picture or the right description on Facebook. Those were all RDF-based tags that were part of what the semantic web was supposed to be, this democratizing thing where you can tag all your content in different ways and make these assertions that people could then harvest and present in whatever way they thought was useful. The point of it initially was to make every individual account the same, produce their own content, be the owners of it, and then offer it to other people with the tags of, I said I liked a post on Facebook. That's something in my content box, not part of Facebook's data store, but I still offer out this assertion to other people so that they can make apps that are based on it. And this is what the same principle that powered, if you saw several articles in the last week of Tim Berners-Lee announcing something called Solid, D-Web. This is the exact same principle that that's based on. But last time this was tried, basically the only thing that worked was for people who wanted to get into the big social networks. Unfortunately, none of the individual level stuff ever took off. And perhaps trackback links on WordPress blogs were pretty successful too. So my worry is that we're kind of in this cycle, and we're very exuberant right now, and we're glad to be building things, and that the investment craze is kind of settling down a little bit. But we're not, as others were saying, we're not really focusing on getting people to want to use any of the few things that exist in the space. If you look at something like people's consciousness of privacy and what they need to do to protect themselves, there was no uptick around before or after GDPR, the new big European privacy legislation came into effect, but it still happened. So that was a purely kind of political thing. It wasn't based on kind of public demand. Now, if you compare that with Bitcoin, early last year, of course, everyone and their mother was talking about Bitcoin, but if you compare it to something like Fortnite, which has consistently maintained equal or greater popularity as Bitcoin ever had at any point. And now this notion of having fun that Brewster Kahle was saying starts to be much more interesting. It turns out that people are motivated by kind of gamification and money, of course, but people want to enjoy using the things that are available, or they won't. So how do we prevent something like this? Anyone who's used Linux for any amount of time remembers a heap of articles every year saying this is the year, this is the time it finally happens. Linux is going to be what we run on our desktops. And it really never happened. Like, it's still not the year. Every other device in the world runs Linux, but not the desktop. So if you look back at the main problems that all of these kind of what was, we think was some of the main problems with this was the user experience, both for developers and normal people. So if you take the semantic web, for example, that's all XML based, and this RDF is fairly convoluted, and this link, there's a lot of W3C specs on how that works, and absolutely nobody had any idea how to use it. And at the same time, we operate in a world that is governed by political systems, and they're not going to disappear just because we have governance on the blockchain. Things like GDPR will shape how these systems will be utilized or demonized. So take an example of Tor that has kind of landed in this hole of never being used except to talk about how bad things happen on the Tor network. So Tor, as a peer-to-peer system, is extremely similar to the philosophy of that a lot of blockchain people have, but it kind of got ahead of itself and it got put into this bucket of badness. And if we don't come out with things that counterweigh the badness argument that people are making about cryptocurrencies and Bitcoin in particular. I mean, if I talk to my family and I say, I work in blockchain, they say, oh, what's blockchain? I say, oh, have you ever heard of Bitcoin? And I think half of my family members immediately ask me if I'm a criminal. That's not great. And that if we can't change that sentiment, then it doesn't really matter who has the best protocol or if it scales really well. So this seems like it's going to be a problem. With that in mind, what I would like to show you is some recordings that we made a little while ago on an earlier version of a product we're making that's all about usability and trying to get some of this stuff into people's hands. So the first demo is of a command line provisioning tool for Polkadot. Polkadot is one of the easier ones to install, but we thought it could be easier than that. So here you see downloading one binary and running it to download the Polkadot binary, and then we're connecting to the UI that Björn shown earlier that introspects the running node. All right, so that was just running Polkadot locally. That's all well and good, but maybe I have my own VPS provider as well. So this is an example of me spinning up an instance in DigitalOcean just with a few commands. Again, just downloading the binary, setting one variable, environment variable, that is the API key that I'm creating. And then running one command to set up a Polkadot VM. And that itself translates into these lower level commands, but you can always kind of see what commands underlie the simpler commands, but we strongly believe that you need kind of these like super simple abstractions. So I won't spend too much more time on that one. Basically, the VM spins up, and the UI that you showed earlier relies on connecting to localhost via WebSockets. So after this provisioning is done, we can easily set up an SSH tunnel to the VM, and the UI connects through the tunnel port into the VM without having to know anything about it. Okay, so last example, this is all well and good for developers especially, and right now we're only supporting development tools. There's no apps in the framework yet, but the idea is that once we do have those integrations, that it becomes equivalently easy to do via a web interface. And this interface is running locally, so again, just one binary, and you've got a way to visually configure these things. And again, the exact same thing is happening here. Polkadot is running locally. There's an iframe that embeds the introspecting UI that you saw earlier. So this is actually the previous version. We'll be showing the next version at the Web3 Summit that everyone was talking about. So hope to see you there. And that's it.
Thank you, Patrick. Any questions for Patrick?
Like DigitalOcean? That particular selector is just selecting one thing. So this is just deploying one thing into one thing. Are you leading at something like why are we using kind of replicative? So why wouldn't I just press Polkadot and then click install, or? I'm not sure I understand the question, but the reason why we configured the DigitalOcean in this particular wizard was that there was no provider already. So we're setting up the new provider to spawn the VM in. Yes, any box with SSH, you can use this to deploy to. And it's specifically not Kubernetes-based because that just doesn't work for most personal and local host kind of things unless you want to run Minikube and dedicate 4 gigabytes of RAM to it.